Let me do it.
Okay.
All right, we're talking about KAS proxying requests to Kubernetes using gRPC.
Uh, Yeah. So agent and KAS are modular monoliths. Here are the modules. One of the modules is Kubernetes API. It's two parts. Two main parts are this is for part of KAS, this is part of agent. Here we have the definitions of the gRPC protocol. They talk to each other. So this is basically it. Make requests. So agent exposes this service, and then it's only one RPC, which is to make a request to the Kubernetes API, as it says. And it's a stream of request parts, and response is a stream of response parts. Um,
What is gRPC
it's
tool.http
it's
request?
a
Is that built
package
for this
here.
purpose?
So it's a just here under two gRPC two things for gRPC. Extra stuff. So we have this HTTP request defined here, and the main thing is
Oh, you built this? This is part of KAS.
yes, it's all
Okay, this
here.
is not a generic library that somebody else
Now,
built.
now we import it from well, this
Okay,
project.
internal. All right, yeah, yeah. Okay.
So this is the request, and this is the main thing. Uh, One-off message. So it means only one of these can be set, and that's what it's a stream. So you send the first thing, which is the header, then the data multiple times potentially, and then the trailer, and then there is upgrade data as well. And we have the automata options here that tell there's a mechanism that enforces that these arrive in the certain order. So first allowed field is one. So header must be sent first, and from header allowed transitions are two and three, so it can get data and trailer from the header, and from data it can also go back to data. So it's a finite automata encoded in here,
What
and
about the upgrade? Doesn't it? So how upgrade is used for upgrading to WebSockets?
it's used for any HTTP upgrade traffic, which is in practice WebSockets and Speedy, because Kubernetes
So
uses
how does that
Speedy
one
or
get sent if that's the last thing you send? Or you send the header and then you send a trailer and upgrade. You don't send any data, but then what happens? How
yes,
does the
because
data go?
upgrade requests don't have data. It's a GET request without a body. So you don't send the payload. But once you upgrade, so you get the header, then you go to the trailer, number three, and then from trailer you go to four, and this is data, and it can repeat four, four, four,
Okay,
four
but
several times.
now it's upgraded. How do we send the bytes through the WebSocket?
Upgrade data is just a chunk of upgraded data.
Oh, okay. So the
Yeah.
header was the thing that upgraded you.
Yes. Header is
Okay,
just
the
here.
upgrade header is how you got upgraded to begin with.
Yeah. And it's
Okay.
the header, the HTTP request. It's here. Yeah, it's a bit confusing. HTTP, where is it? Oh, it's different file. This is gRPC tool, and this is proto tool. Yes. Let's open this one as well. So this is the request, like method. You see, there is no URL here. I mean, no host, no port. It's
Right.
designed to just talk to
It's got a path.
outer. Yeah, there's a path, yes, but no IP or port or URL, full
Well, host is
URL.
a header anyway, but yeah, so we would only the
No,
only
I
thing that's
mean,
missing is
yeah, I
the
mean, where to connect to, it's not here
yeah,
because
yeah.
it was
Which is
built.
just the first line of an HTTP request is what's missing.
Yeah, basically. But yeah, so you get the header, then data is just body of the request, and then trailer, and then upgrade data. And then this was the request, and the response is kind of the same one off, which is header, data, trailer, upgrade data. It's the same thing basically, except the header is HTTP response from that proto tool, which has the status code, the string status, so like 200 OK, and then the headers basically.
So you have basically like 90% of what we need to build a generic um, both sides of an HTTP proxy over gRPC. You have all of that already here, except for just where to connect to.
Yes,
Needs to also be sent through.
yes,
And um, oh, can you actually now show me how an HTTP request is translated into gRPC calls? So like the server
yeah,
takes actual HTTP and then converts.
yes. So the server is the main thing here is the proxy, and the main uh, so proxy is this method. It's wrapped in some other things too for cancellation, in tracing, and so on. So it's just a normal HTTP server from standard library, and then eventually the request gets here, and this stuff is for course. Most like all of that is for course, and then we check that it starts with a certain prefix. Then here we get authentication, like authenticate the request, get credentials, agent ID, user ID, impersonation config, and the
Does
credentials.
authenticate and impersonate requests do? Does the authentication, how does that work?
Um, there are multiple ways to authenticate. We look at the request basically and inspect the request. We can get a WebSocket token, GWT
Or
token in the
to
header, and
GitLab
then we
at all?
support. Sorry?
Does it go back to GitLab to check permissions for the user or anything like that?
Yes. So we get we extract credentials here in this function, and then we, depending on the credentials, we make a particular request to GitLab to actually check if it's authenticated, if it's authorized to proceed, like both basically authenticate and authorize. Well, it depends on the credentials. So here we get allow, if it's a CI job talking to us using CI job token, we use allowed agents for CI job. It actually calls GitLab. Here's where we call GitLab through a cache, GitLab client. Yeah. And then if it's a cookie, we look at the cookie. There's a separate authorized
Get
proxy
this
user
session
RPC.
from or something, or you're
Hmm?
using GitLab? Oh, you're using GitLab again. You're calling GitLab with the cookie to figure out
Yeah,
information about the user.
yes. Then if it's a personal access token, we also call
Where do
this.
these requests come from, though? Aren't they all coming from GitLab already?
Which request?
The HTTP request that
The
first
HTTP
got to.
request is coming from the browser or kubectl or UCI job, anywhere basically from the network. This endpoint is exposed to the internet
Okay.
via
And,
load balancers and Cloudflare and whatnot.
and this is used in the browser for some UI element that just loads stuff directly from KAS
Yes,
using your same cookie from GitLab.com.
it uses a separate cookie actually, but yeah,
Okay, some authentication flow that's getting that cookie for you. So I'm imagining this is embedded in JavaScript that's on GitLab.com though, right? Or no?
what specifically the client like talking to us? Yes, it's
It's coming from the
literally
it's
front
coming
end.
from the domain GitLab.com. So
Um,
wouldn't it use the same cookie? Or
y-
but like it's
yes,
it's communicating with a different server. So it needs a different
it's a different domain, KAS GitLab.com, but
right. So
it's just
either a
there's a separate cookie basically. Maybe we get other cookies as well, but we only look for a specific cookie that is for KAS.
okay.
So anyway,
Cool.
we look at the request, we figure out where the credentials are, and depending on the credentials, we call this or that endpoint of GitLab to check if it's a valid credential.
Hmm.
And then from the request, we also get the impersonation config. That's not always, but here, for example, uh, well, okay, that doesn't matter here, right? And then this is for WebSocket token because with WebSockets you cannot establish. You cannot pass headers properly. So it's a workaround to anyway, doesn't matter again. Here we clean up the request. We don't want to pass various credentials to the Kubernetes cluster. We don't want to proxy them. So we drop lots of things here, cookies and everything. Various things. So if it's a watch API, this is a specific endpoint that we built for the front end. So /watch on the KAS endpoint. That's an aggregated watch endpoint. So again, that doesn't matter. So this is the proxy request, the main thing. So yeah, here that's the kind of utility type that is in the separate package that we use. Its job is to convert inbound HTTP to outbound gRPC, as it says. We give it a client. So you see the client that it uses is a kind of quite generic thing, right? This is the PD stream request response. These are the types from the proto from
Can
here.
you go back? I'm kind of confused. What, can you go back to where that's used, that client? I don't understand what client means in this context. You have a thing that is responsible for converting HTTP into gRPC.
Yes, and it needs to establish a gRPC connection to somewhere.
Oh, okay. So this is new client means to say open a gRPC connection.
Yeah,
And
that
that
connection.
function, you're passing a function in there so that it can call that function, which will then later give a connection from a connection pool.
Yeah, this is a connection pool that does the routing. So from the perspective of this type, it just makes a gRPC connection to the agent.
Mm-hmm. Okay, so
Doesn't actually
open.
go to the agent directly usually, but that's the abstraction basically. You call well, in practice it's this RPC, but yeah, you make a request and the signature is basically this is the signature: send, receive, client. It's a client stream, and you send HTTP requests and receive HTTP response. So these are the object types that I showed before.
Okay, right.
It's the same
Okay.
package, gRPC2 package. Yeah.
And if we go back up
Mhm.
here, okay, so now I'm expecting to see some code that actually translates
Yes. Yes.
these
So
into those question
yes.
response.
So we set everything up here. It's quite flexible. Well, yeah, it various uh, we inject various functions because lots of the behavior is pluggable. All of this is functions. It's just aliases for functions, basically. And then we call pipe. We give it the HTTP response writer and the request and some extra stuff that is whatever you want to pass. This code is generic, so you can kind of smuggle something along with the request that you pass, and then the thing you call on the other side knows how to interpret this extra proto message. In practice, we pass some impersonation information here, and it's optional. But anyway,
Okay,
looking at this code, that's the logic. We call that new client to make the outbound gRPC request. This is our outbound client. Then we pipe the inbound to outbound. So we um, send the header, send the body, and send the trailer. This is our conversion of the request and the body and the trailer. That's it.
okay.
In the
How does that
standard,
work for WebSockets? You're saying you will send all three of those to upgrade a WebSocket, and then at that point you can start receiving
yes,
responses.
upgrade is handled just below here. So we send this non in all cases because to upgrade the WebSocket, you send a GET request with certain headers. So we send that request, and then there is no body in that request. So we send there's no body. So we send zero body messages, and then we send the trailer.
Okay.
Once that's done, we look at the header upgrade. If it's set, then it's an upgrade request. If it's not, we send the close. So it's just a close send. That means the client tells the server, I'm done. I have finished sending all my stuff to you. I'm now receiving. But yeah, if it's an upgrade, then we don't send this, right?
One of the things I'm wondering about is like buffering and streaming and loading everything here. Like, is there a point in time here where we're loading the entire request or response body into memory and buffering it in Go, or are we always we're chunking everything
Yes.
and and piping it through one chunk at a time?
Yes. So that's where it happens. We use 32 kilobyte chunks. We read in the buffer and we send.
So we because every part of the body is a separate gRPC call. So
No, that's
every
just message.
message,
Yeah.
yeah, every part of the body is a separate gRPC message
Message on this stream.
on the existing BiDi stream, which we have.
Yes. That's why it's a stream.
Yeah.
It's a stream.
Okay.
The response is the same. It's a stream of messages. And the messages, well, we can use even a smaller buffer if you wanted to, but yeah, we use 32 kilobyte buffers.
And when we get response data, it's always in the stream as body responses that are buffered in some way, or the response should have headers and body as well.
Yes. So this is the response handling here. So we send the request and the body and close it or not, depends on if it's an upgrade or not. And then we start to send the reply, the response, back to the client. And visitor is the thing that enforces the correct ordering of messages. So enforces that automata that is described as options
Mm-hmm. Yeah, I remember.
here, right? That I showed you all this next allowed field, blah, blah, blah. And that's the thing that is the visit. It's the
Okay.
stream visitor. So it basically keeps, if you look at it, it keeps receiving in a loop until it gets an EOF or any other error from that outbound client. And then you can set callbacks depending on the which of the messages you get. 1, 2, 3, 4. So one off. In the one off, we have 4 options that we can get, right?
Mm-hmm.
Basically. And where is it? These are the field numbers for the response header, response data, trailer, and upgrades. 1, 2, 3, 4, right?
Mm-hmm.
So define callbacks which get the specific one-off field, and they can do stuff depending on which callback.
Okay, and we're only getting one of them at a time. Like we're getting our function callbacks are called every time we receive one message. They're not,
Mhm.
it's never buffering them all and then sending them all
No, so we
sequentially
get the
afterwards.
header, we like the header message, and we get status code, we get the HTTP headers in it.
Header.
We can like do various things, remove stuff that we shouldn't send back. And
But what aren't we gonna get? Okay, we're gonna get the entire header in one go. Like we're not.
yeah, because that's how it works. I mean, you read the whole head. Yeah, it's not working on the byte level, right? It's not proxying a stream of bytes. It's proxying a header and then chunks of the body.
Yeah, that makes sense. I mean, I think that's probably what most web servers have to do, right? They probably have all the headers at the same time anyway.
Yeah.
I'm just trying to, yeah, okay, piece together this.
So the
All right.
header, then we write the header, well, set the headers here in the merge headers, then write the header. So this is where we send the header back. And then we flash it. And then we get
Oh,
data
so
from
that's a
code.
normal Go web server call there where you write the header. At that point, you have a response writer that you're just writing straight into.
Mhm.
Okay.
Yeah, this is the response writer. We just write after each write, we flash so that the buffering in the response writer doesn't buffer.
Is that
Otherwise, things
would
get stuck.
do you just if you don't flush it, you just leave it up to the implementation to flush, or it never flushes
It
until
never
you tell it to
flashes
pull it?
automatically. It only flashes when you close the connection. I mean, return from the handler, basically.
Okay.
But if it's a streaming call like Kubernetes Watch, or if you're looking at logs in Kubernetes,
Right.
for
You need to
example,
keep flushing.
you want to,
Otherwise,
yeah,
you
you
would
want to
never get the
send,
response until it
yeah, otherwise
finishes.
you wait and nothing comes, but actually there were a couple of lines, for example, and you never get them. So the intention here is that we read and we immediately send back. We don't try to combine several buffers into a single response, right? We just, what we got, we immediately write and we continue. Well, flash and we continue. And then trailers, and getting a trailer means we've got the whole response, but then if it's an upgrade and the code is switching protocols, so the server actually wants to switch protocols, we use a sentinel error and we check if it's that sentinel error, we continue here, returning no error, basically. And otherwise, we close the outbound client. So this is where uh, we close the gRPC client to the agent because we have consumed everything and we are not going to send anything either. So we need to close it. And yeah, this is the response handling except for the upgrade part. And the upgrade part, I'm just trying to go back. So this is the thing, right? And then the upgrade part is here. So if if it's not an upgrade, that means we're done. If it was an upgrade, I mean, if it was a request to the client wanted to upgrade, then we need to check if the server actually upgraded, right? So if it didn't, we are not proxy anything. If it actually accepted the upgrade and upgraded, then we need to pipe the upgraded connection. And that's this. The difference here is um, we pipe from client to remote and we pipe from remote to client. Initially, I implemented this as concurrent operations, but the HTTP one uh, when the standard libraries HTTP server works in HTTP one mode, it doesn't allow this. So it wants you to, it's documented there. It wants you to first consume the body. As a server, you need to consume the body, and then you can only start replying. Otherwise, bad things happen.
But messages can be moving in both directions at that point in time.
Uh, After the upgrade, yes. Before the
Okay.
upgrade, no. So yeah, here we pipe the upgraded connection, and here we do consume them concurrently in both directions. I mean, do pipe them concurrently in both directions because at this, after the upgrade, it's just a stream of bytes. We don't know what's on it. It can be anything, can be WebSocket, can be Speedy, can be some new protocol.
Okay.
We don't care. It's bytes in each direction. And here we use virus again. Yeah, we hijack the connection from the incoming connection so that we treat it as a raw TCP connection, so netcon. And then it's all virus plumbing. And then we use this other type, which is inbound stream to outbound stream. It's also for piping is used in several places. So we have two functions, pipe inbound to outbound and the other way around, outbound to inbound, and then we just pipe them. And the implementation is straightforward. It basically handles the abort. That's its main purpose.
What are
And
the
this
things that we're
works.
piping into both directions there? What are the data types that are going back and forth at this point?
Yeah,
Uh,
we are just piping the upgraded data in from the client to the remote and from remote to the client. Yeah,
we're still dealing with those protocol buffer definitions for response data and request data.
yeah. Yes. So here we are also using the response visitor, the same stream visitor we just used before, but we now configure it only with a single callback, and we tell it that we are starting from this state. We finish it receiving the trailer, so this is our start state of the finite automata. And yeah, we just basically get bytes and write bytes into the client stream, the stream that connected to us. Yeah.
Yeah, that's what I was kind of curious about because you were saying reading bytes and writing bytes, but we're still dealing with the protocol buffer and whatever
Yes. Yes.
those
It's
things can
raw
actually
bytes
code.
from the remote, but yes, everything is in messages that we, from one side, we have an HTTP connection and
Upgrade data
and
contains an array of bytes and three other things.
yes, it's the data.
That
So yeah,
hover thing was showing me extra fields before. That something
uh,
generate that's the generated.
yeah, it's built-in stuff. I mean,
Okay,
implementation, proto implementation stuff.
yeah, okay. But it really the only thing in the protocol buffer definition is the bytes, and that's all implementation details that it's using under the hood. Okay.
Yeah, yeah,
The other
it's
thing
all
I was
generated code. This part is
yeah.
generated.
The other thing I was wondering about is like reusing connections. I think I understand everything will sort of be reused in that. I mean, the client, which is a browser, is going to open a HTTP2 connection to um, the KAS web server, and it'll be able to push and make as many requests as it wants down that HTTP2 connection. Or yeah, well, I think that HTTP has different terminology, but it have a single TCP connection which is pushing lots of HTTP requests down, and then KAS will have a single gRPC connection to Agent K, but that's composed of many gRPC streams that it's opened up, one per request. So all of this stuff can happen concurrently with really only one TCP connection between each party.
Yes, uh, but in because there are multiple KAS instances, or maybe multiple KAS instances, you may route some requests through one KAS instance and some other requests through other KAS instances.
Well, if the browser is connecting to KAS, then the browser is probably only going to open one TCP connection when it loads the page. So maybe.
Yes, but if you have a cluster of KAS instances and several agents with the same agent ID, so several pods of agent ID, they all connect to potentially different KAS instances. And each of them has 2 to 500, I think, gRPC streams open for again, logical gRPC streams. They can be on a single TCP connection. But each of them connects separately, right? So KAS, when it needs to find a connection from an agent, it can go via the same KAS instance if it has a connection. It prefers that because that's less network I/O. But if it doesn't, then it looks for connections in other KAS instances, and that's where it can pick this one or that one, whichever replies faster, basically. To
Okay, that makes sense. But like talking from the browser to KAS,
Yeah,
it's
it's a
just gonna
single
be, it
connection.
probably should be just one if it,
Yeah.
unless they have like, two browsers open or something like that.
Yes, yes.
The user's kind of in control of that, how many TCP connections they open to KAS. Um,
Mhm.
okay, that makes sense. What was the other thing I was thinking of? Well, let's go back to the diagram now and kind of see how that relates to this topic.
Do you want to share
Uh,
the screen?
yeah. So that architecture could take care of this kind of situation, assuming there was something like the agent over here, and we're going through something like KAS here. Um, and we could do it more directly, which is this is what you're actually doing. You're saying
Yes.
the user's going from there to there with the browser because this is internet exposed, and maybe there's one of the things that that means is that you have to do this to authenticate users. Um,
Mm-hmm.
so you have some auth over here
Yeah.
because of this, but without, but otherwise, if you did go through the flow that this green line is going, we handle auth over here, and this thing just trusts what it's told to do because it's being asked by GitLab to do it.
Yeah, but you
Um,
in that case you will have one more network hop. Be-
on the entire open
If your
connection
proxies will work
for the
first.
life of it. Yeah.
And there are already Cloudflare, Google Cloud Load Balancer, HA proxy, so and maybe two cloud load balancers actually. So yeah. And caches the credentials for like 5 minutes or something. Yeah. So yeah, it's a bit more hurts latency a bit less.
Yeah, I can see what you mean. I mean, the downside is the URLs, though, that it might well be exposed to users. Um, the other advantage
Oh,
here is that this has the same domain name that you're using, the GitLab.com
so
application.
you have HA proxy in front of everything, so you can send the request to Workhorse or to CAS or to anything else
Based on
based
path-based
on the
routing.
path or the host name or both or whatever.
Okay, yeah, that's true. So yeah, the advantage is just having, yeah, I mean, the advantage of this then becomes just not having to check auth in KAS, and KAS remains a bit simpler and it's just proxying.
Mhm.
But the disadvantage is that the latency of this network hop is persistent for every request and the entire duration of this thing, as opposed to having just one auth check at connect time.
Yes, that's the kind of let's say explicit downside. Then there's also a less obvious downside, which is the more hops you have, the harder it is to troubleshoot where the problem is. And
What
that was
doesn't
quite a pain.
doesn't this need to happen, this auth check, every logical HTTP request that comes through?
Uh, I don't know. Right now it doesn't happen because we cache it for a minute or 5 minutes or something. It's
Oh,
completely.
you're using caching, but you're still kind of logically you still see it as a different HTTP request, but you read from the cache to check if
Yeah.
it's the
Yeah.
cookie is valid or whatever.
Yeah. Hmm.
Okay, that makes sense. Yeah, no, because that was what I was curious. Like this doesn't really have any memory of the previous HTTP request apart from
No.
caching. Okay.
Yes.
It's not keeping a state machine of how many HTTP requests it's got from this user or remembering that. It's instead just going, okay, I've seen this token before or something. I can
Yeah. Yeah.
trust
Yeah.
it. GitLab already told me this token can do this thing.
Hmm.
Okay, cool. Let me put
So
note
what I
here.
was saying is the non-obvious downside is the more hops you have, the more hops you need to configure correctly because each of the level 7 things and level 4 or 3, I suppose, they all have various timeouts. Idle timeout, read timeout, write timeout, max connection age, and so on. So the more hops you have, the more hops you need to configure, and adjusting them for long running connections has been a pain, actually. I needed to
Yep.
ensure that HA proxy is configured more or less correctly. Load balancers configured. I think they were okay. And yeah, every time users report a problem, you're like, okay, where exactly is this? So it's
It
much
makes a lot
easier,
of sense.
like for just quick request response, this is basically a non-issue, right? Because you have such a huge volume of request responses that it's a well-trodden path and there are no issues basically. But if you are having requests that last for an hour, suddenly all those hops, have an opinion how long this should take basically and disrupt your requests. Or they have a chance to do more chance to do this. So the fewer hops, the better.
Okay, this makes a lot of sense. And I just drew this in because this is likely what happens when you have, the gRPC connection is here, but your request ended up here. So we have
Yeah.
to take you to through a different CAS.
Hmm.
Um, and then SSH, since you mentioned CAS is already listening on like so many ports already, I guess it could also be, whatever this service is, it could also be translating SSH into these using the
Sure.
same deployment.
Sure. Why not?
Well, I was when I wasn't really thinking about CAS, and we still haven't really discussed or figured out exactly what this thing is yet, apart from the fact that like I can see in CAS you have like most of the code we need. But regardless, like the point is that, if this thing has the connection, I guess, and you've already proven out it's fine to have one service that listens on multiple ports for different protocols, then I think it makes a lot of sense that we would additionally have the SSH protocol available on this thing. Although the question is still about how we manage the authentication for the SSH stuff and who is actually terminating SSH connection. We have already for workspaces, and I don't know how this works, but there's already Go code that is proxying SSH connections, but apparently doesn't work particularly well. So that's something that like needs to be figured out in this architecture, whether or not we can get it in Go to be translated. Well, it really basically needs to be Go code that's going to convert an SSH byte stream into a gRPC. There's not really any other option for that.
But
Um,
don't we handle all the SSH traffic, not in workspaces, but the Git SSH traffic in GitLab shell, and it's in Go, I know.
right. So we have GitLab shell already receiving SSH and already has your user's credentials. I was thinking about that too, that it already knows your SSH public key from GitLab, and it already has a callback flow where I don't, yeah, I'm not sure if it's GitLab shell, but I guess probably is. I haven't looked into that, but it already knows, like something already authenticates back with GitLab, but when it looks at your public key. So um, maybe it makes sense to reuse that, but then so that thing would have to convert an SSH to a gRPC stream to CAS, which would then be carried through here, um, if we did it that way.
Mhm.
Yeah, okay. Uh, what else needs to be considered here? Apart from like basically now I'm wondering what would be the most logical way to prototype out all of these pieces. Like I'm thinking one option is create a new Go executable that has all of those pieces that you showed me in it, just the server and the just the pieces we need to proxy HTTP into a container that's running from a CI job that's triggered by a CI job. So it's nothing to do with Kubernetes. And in such a case, kind of probably having to rename some code that seems to be Kubernetes, well, has Kubernetes in the name, but isn't specific to Kubernetes. Or there's a possibility of taking CAS and despite its name having Kubernetes in it, adding a bunch of functionality to KAS that has nothing to do with Kubernetes and seeing and prototyping it out and seeing how it looks.
I mean, if we kind of step back a little bit, I think workhorse is probably more like a piece of the monolith itself, that it's even in the same repository, right? It runs on the same host, like always, one-to-one, right?
Yeah.
It's really tightly coupled. It has lots of business logic that works together with business logic in Rails. So it's not a generic, proxy, let's say, infrastructure that is there. I think conceptually, if we want to have long-running connections, maybe we should have a separate single service, which can be KAS, that handles all other connections. And then, I mean, KAS or not KAS, we can rename it if name is the problem, right?
Yeah, no, it's not the problem. I'm more sold on it being KAS now in the sense that KAS has the internal clustering stuff built into it, which we would need if we were to put this stuff in Workhorse. We would need the cluster proxying concept that KAS has, which is I need to figure out which other KAS instance actually owns this connection that I'm trying to proxy right now, or has and it communicating with each other via Redis, right? To do that.
Yeah. Um, I mean,
Whereas
if the connection goes through Workhorse, then Workhorse can talk to any KAS instance.
yeah. But
KAS
I
will
meant if
figure out.
by putting the proxy, if I put the proxy in Workhorse and didn't use KAS or another
Mhm.
service like you were
Mm.
suggesting, then I would need Workhorse to understand the idea of other workhorses and figure out how to come. And probably networking wise, we don't even have a protocol for workhorses to find each other by a host name or anything anyway. Like
Uh,
they're yeah. I mean, they would all be routable by, well, they're all routable at least by the load balancer, but whether or not they can connect to each other, I don't know. We probably don't have a use case for it yet.
so I think if I was designing this from scratch, I would have Workhorse as a coupled thing as it is today, and I would have a separate service for everything else, all that
Right.
route. It can be KAS, but then I would merge shell into it so that it handles all the traffic for those things.
Yeah. Well, it might be yeah, I don't know about shell because the shell has to do different. I mean, I I don't actually know what the shell has to do, but I mean that's communicating with Gitly and putting files into Git in Gitly, so it's quite a different has quite different requirements, I expect.
KAS also communicates with GitLab. Yeah, there's not as much traffic, I guess. Uh, I don't know. I'm
Yeah.
just
I
talking about architecture. I'm not talking about, how uh, for other requirements, Just conceptually, I think it probably makes sense to have a component that is handling all that routing and traffic. And that's not coupled to workhorse to Rails, That's kind of a separate thing, scales separately. That's, I guess, the main
Well,
difference.
scale separately makes a lot of sense in the terms of Rails will have thousands of pods for Rails, but it would not be particularly practical if we had thousands of KAS instances. Um, if if you think about the way the agent is connecting to KAS, it's probably less efficient to have thousands of instances of KAS. Oh,
Mm,
I don't know, maybe not. I guess you've only still got to only at worst case scenario make one hop to a different KAS if you don't have the connection.
yeah, it's not
Uh,
gonna go a snake.
yeah. Yeah, I don't know. Okay, maybe they do anyway. That would be fine to have thousands of KAS instances. Anyway, yeah, I mean, in practice, I don't think I'm going to be merging the GitLab shell stuff in, but it does
Doesn't have
make
to
me
be. Yeah,
think
it's
about
just
whether or not I use GitLab shell as the same. If that we already have SSH connections there and authorized keys and things like that. maybe it makes sense to try to get GitLab shell to proxy these SSH connections somehow.
I think
But yeah,
there's also a lot of overhead that we shouldn't underestimate in configuring all this. And it's in Omnibus, in the chart, and then GitLab.com is slightly
but
different, or maybe
how
slightly different.
how is so Omnibus is generally pretty tricky with these things though. Um, when we're building just Go packages that are just things that listen on ports, it's pretty straightforward to get them into Omnibus. Um, but for CNG, like the KAS stuff is all in there already, right?
Yeah.
Is
And
that
not
how it's deployed? No.
not the agent. KAS, yes. Agent,
Yeah,
not
yeah.
yet.
Yeah, well, in the case of all of what I'm trying to do, um, I need the runner manager to get a binary into my it creates VMs
Hmm.
and then it needs to inject a binary into that VM.
Hmm.
Um, um, so this thing will be packaged with this executable that gets copied into your Docker container. I assume right now we're already doing this for the doing something like this for the runner having a um, right now the runner web interactive terminal does something like this where it injects an executable in there for an interactive session, and then that executable opens up a long-lived gRPC here, and then this thing, what does it come from here? I think this thing is HTTP routable, but we don't use this concept much today because this is an assumption about people's runners that isn't true for most of the runners, including GitLab.com runners. So um,
Nah,
people
you mean that actually workhorse cannot reach, most of the time, cannot reach the manager.
exactly
Hmm.
because runners only communicate with GitLab like this ordinarily.
Hmm.
Um, so that's they poll for jobs, and that is the standard way runners communicate with workhorse. So the assumption about this being HTTP routable with a domain name and a valid SSL certificate and all these other things is generally not held. So
Hmm.
we don't rely on that. Well, we I don't want to rely on that for whatever we build here.
Hmm.
Um, which means that this current whatever is being injected in here is not particularly useful. What I still probably work with the runner team to figure out though is whether or not we want a stream here and these lines all go here through the runner manager and into the container that way, or if the container, this is meant so the container tunnels out directly from inside itself. But that's sort of more of an implementation detail about whether or not we just have one more stream here open at all times. Okay.
So runner manager, is it a single instance, or is it, I mean, are there replicas basically of the same thing, or it's a single thing?
Well, yeah, you usually have many runner managers, and but although the runner managers that do auto scaling, you don't need that many of them. But they runner managers are like runners that I think they only appear like one of you'll just see
What I
one
mean,
instances of
I know you can have multiple runner managers, but are they, each of them is a distinct identity, or do they have replicas of each of them?
I don't know. They're a distinct identity. They have a different registration. They have a different ID here. these are different runner managers, each of which would be like a single go process that is polling GitLab every
Okay.
6 seconds or whatever it is. And GitLab will identify and know about all these runners independently. There's no load balancer that sits in front of them or anything that GitLab like kind of thinks that they're all one thing or anything like that.
Okay.
I might be wrong about that, but I'm pretty sure that's how it works because each one of these is an auto scaling runner manager, which means that they can provision VMs and run as many jobs parallel as they want by just provisioning VMs to run the jobs in. Um, which is a little bit different to how normal runners work with, well, the shell or the Docker runner, they just use their local environment to execute things. So, their concurrency is sort of limited to an extent of how much they can concurrently run on that one VM. But then there's the Kubernetes. I think the Kubernetes one would technically be a runner manager as well, in that it would create pods. Um, yeah. So I guess I still need. I mean, at this point, I think this is the least risky part now that I've seen everything you've showed me, and if we can just reuse that code and figure out. There's still a question about. It seems nice if we could imagine a scenario where KAS is already running on GitLab.com and probably already running for some customers, and it doesn't architecturally require anything new for it to start accepting more HTTP requests that are bound for a different place.
Yeah.
So it seems nice to imagine extending it. But yeah, again, the name is kind of becomes weird. But yeah, obviously that's
You don't
not the
have to
biggest thing.
expose the name, right? We have HA proxy in front, so we can run it on a path of GitLab.com. It
Yeah, yeah.
will,
And
it will be a separate port on exposed on KAS itself, but it doesn't have to be KAS GitLab.com address, right? It can be traffic can come from GitLab.com/our new stuff, and that can be sent to KAS on a new port. So
cool.
KAS
And then
is
I
not
can
in.
reuse the server aspect of this, but I need to then figure out, well, I can sort of probably reuse the agent aspect of this, but I need to tweak. Well, I need to tweak the protocol buffer anyway to include the connect address. And I then I need to make sure I can build the binary for the agent in a way that can go over here with the runner, which annoyingly, well, can't then live in the runner monorepo because the protocol, well, there's a mess of protocol buffer issues.
Yeah. Ideally, we build the binary in CNG, but if you want to, support various architectures, then you can.
But
It depends.
the
But
runner is released separately from
yeah, yeah.
GitLab anyway, so it also needs to build the binary. But yeah, it could probably clone it from here and build the binary from here, and then it doesn't even need to know much about the internals of it. It doesn't even need to know the protocol buffer definitions if it's just copying a binary over here that's going to open connections back here. And that's just build process stuff for the runner. All right, what else? What else is tricky about this? Yeah, this basically HTTP thing is going to work, but need to figure out what it would mean to unpack an SSH connection and stream it through gRPC. I did find
Look,
something from Teleport that was doing it, but
it doesn't have to fit into the, well, obviously it doesn't have to, and it cannot fit into the HTTP RPC. You just create a new RPC, create new stream of requests, stream of response messages, and just send bytes over the pipe, basically.
and then this side forwards those things to an actual SSH. Well, that's what I'm wondering about. What does this side do? It receives the bytes and it pipes it through to an SSH command or something. That was
Something like this, probably. Yeah, I'm not sure how it should work.
because with the HTTP one, we've got an HTTP client on this side. I assume, making their, yeah, we're unpacking them and sending them through an HTTP client.
Mhm.
SSH would need an SSH client. Um, anyway, okay, that makes sense. But I have a feeling that, yeah, with maybe that is how, like, with that being what we were doing for something like that for workspaces already, I suspect there may be some issues I need to understand better. But I did find this stuff with Teleport was supposedly doing SSH tunneling over gRPC as best as I could understand what they were talking about here. But they also had some Go code with which maybe, well, like from what I could see, was open source in a way that was, but yeah, was Apache licensed. Um, but yeah, I don't yet know what all of this means and how applicable it is. But
An example, at least.
yeah, okay. Well, yeah, I think what I'm going to do next is try to wire some of these things up. I may be, yeah, I'll probably just hack on the KAS repo to try to get all those pieces working with the runner and see whether I can get all of that stuff in there.
This might be relevant actually to you. I'm implementing a feature where I need to make an HTTP request from KAS to the Kubernetes API. Slight difference. KAS is not a server that accepts a request and proxies the request, but KAS is the client itself that makes an HTTP request as if to the Kubernetes API. So there's a little bit of a difference, but I'm extracting this into a separate reusable thing, and maybe this will be useful as well for something.
Yeah,
Just, FYI.
yeah, I wouldn't be surprised if something like that comes up. But yes, I think probably if we want to reuse a lot of that stuff, a lot of that code, I think really the biggest thing will be trying to tease out Kubernetes from every aspect of it where it's not needed and trying
The
to put
generic
those into.
stuff is not tied to Kubernetes. Yeah,
Yeah,
but there
but
is,
all the package naming was, but yes, otherwise most of the implementation details looked pretty agnostic to Kubernetes.
yeah,
Um,
stuff that's related to Kubernetes and proxying to Kubernetes is in the Kubernetes API package, but
right,
it uses all those things that are somewhere else. And yeah, they're not related to Kubernetes.
right, but there was a lot of the code in that package that I would want to use in the
Because
Kubernetes.
it's, yeah, it is specific to that and conceptual, server that is a proxy for the Kubernetes API. That's why it's there. But yes, I mean, some of it is kind of generic, but it's impractical to untangle it completely. Just
Okay.
too much abstraction will be horrible to understand what's going on.
Can you show me like what is the part that you think I would be duplicating from then? Because I was thinking that server.go file, which was in the Kubernetes package, would be the point to um start making that or proxy.go. Like there's a lot in here
Yes.
under Kubernetes API.
So it's all specific to the Kubernetes API proxy, right? But I mean, it's built in a way to work for this specific use case, but and stuff that is not specific, at least most of it has been already extracted into gRPC tool package and proto tool package, and probably
But
other.
this file is 1,000 lines of code, so I wouldn't want to make another one that was like almost exactly the same as this.
Yeah, but like this is impersonation, for example.
Okay.
Lots of it. It's not related to, like, you don't need this at all.
Okay.
So there is
Uh,
quite a lot of stuff that is specific to the Kubernetes proxy.
okay, that's all impersonation. Uh,
Without impersonation, you don't need it.
like auth stuff, I will want. I will want the
Some,
same GitLab auth logic.
some of it, yes, probably at least a half of that code.
Yeah, agent ID and token is Like I'll definitely be wanting to get some token, but no, I won't want anything to do with agents.
Mhm.
Yeah, okay. But okay, I see what you mean that there is that you've already extracted a lot of things. So I'll just have to go through this and figure all that out. Okay. All right then. Any other things we should talk about? Okay.